We'll continue with the last video, and there we stopped with what is meant by effective stress, how effective stress has been used. So, effective stress is a numerical difference between total stress and pore water pressure. So let me see a small example here. Here in a soil sample, two different layers of sand and clay exist. So one is for soil, sand is been there, second one is clay is there. So bulk unit weight or moist unit weight of the sample till H1 distance is 18, H2 dry unit weight is 13.1 kiloton per meter cube, and clay is having of 19.8 kiloton per meter cube. Its height is 4.5 centimeter or 4.5 meter. So now we'll see through calculate total stress from different till last base of the soil sample, gamma 1 into H1 plus gamma 2 into H2 plus gamma 3 into H3, where gamma 1 is dry unit weight and gamma 2 is bulk unit weight and gamma 3 is unit weight of the soil sample. So you can see here it is clear that dry unit weight multiplied by 12, 13.1 into 2 and 18 into 2.5 plus 19.8 into 4.5 is what we have produced, and finally we arrived the total value of total stress which is acting at the base of the end of the clay layer after the sand deposit and clay deposit is 160 kilonewton per meter square, and where pore water pressure we can calculate is, it has been clear that the unit weight of water is been started from here. So it is saturated, the soil sample is been saturated here, clay only in saturated condition. Hence we can take from this point where the blue mark it has been indicated, from here the soil is been saturated condition. So we can calculate the pore water pressure with the help of unit weight of water multiplied by H1 plus H2. So this one unit weight of water is been 10, H1 plus H2 not, it is H2 plus H3. And now if we calculate H2 plus H3 value, 2.5 plus 4.5 which is 7. If we multiply 10 with 7, we are arriving with 70 kilonewton per square meter. And finally our effective stress value will be 160.3 minus 70. We are going to get around 90.3 is our effective stress. Or we can calculate with the other aspect like this also, another point is there. So anything we can calculate if you substitute all these terms of gamma 1 z1, gamma 2 z2 and gamma 3 z3, we can arrive this equation also. So this is the first best example. And finally, once after obtaining all the values of total stress, pore water pressure and effective stress, we need to draw a pressure distribution diagram, how pressure is been varied from top to bottom. So at the top it was 0, and the bottom at first layer 26.2 kilonewton per square meter is the pressure. At 4.5 meter depth it is 71.2 kilonewton per square meter, and at depth of 9 meter 160.3 kilonewton per meter square is the pressure of total stress. This includes unit weight of soil plus unit weight of water also. Pressure carried by the water particles, pressure carried by the soil particles has been added here. And if you take only due to pressure carried by the soil water particles, so usually it has been represented that water particles are here from 2 meter depth till 9 meter depth it has been existing. So if you calculate the pressure at this 4.5 minus 2, 2.5 is depth, gamma unit weight of water is been 10 into 22.5 it will be 25. And whereas if it is been depth is been around 4.5 into 10, so it will be 25 plus 45, so which has been 70 kilonewton per square meter. If we deduct these two values, we are going to arrive this one. 26.2 minus 0 will be 26.2. 71.2 minus 25 it is 46.2. 160 minus 70 you are going to arrive 90.3 is our final pressure distribution diagram. Like this we have to calculate our pressure distribution diagram, or how the pressure is being varied from one end to other end. Okay, I think hope you understood how to calculate effective stress. Thank you. We'll meet again in the next session with small videos.